So from A to B, two ways of thinking of it, either backwards down there and forwards along there, so -3 plus 1, -4, -2, -8, +5, or just look at the jump. So from 3 to 1 is down 2, from 4 to -2 is down 6, and from 8 to 5 is 3. B to C, similarly, 1, -2 to -5, that's down 3, 5 to 7 is up 2, and then A to C, we've got 3 to 7, 4 to -5, 8 to 7. So the length of the sides, I just do the square root of -2 squared plus 6 -6 squared plus 3 squared, and similarly here and similarly here. Yes, Pat, sorry.
Would you -3 start?
Where are we doing?
First one.
Here,
Yeah.
from 8 to
5.
Thank you. Thank you. So yeah, we do the square root thing. I hope you can see, even without having to do anything, these two are going to be the same length, aren't they? Because although the x, y, z values are different, they're the same numbers. So when we square a square root, it's all going to be the same. So you get 7 and 7, and then the other one is 7 root 2 or root 98 if you left it simplified. And if angle ABC is 90, now that shows just how badly I've drawn my diagram, but if it's isosceles and right angle, then the other two angles got to be 45. So that's a sort of common sense thing which we're often expected to be able to answer. So let's now look at a slightly harder question. So here we're given, these aren't position vectors now, but we're given the journey from P to Q. You know me, I'm going to straight away put it in a column. And the journey from Q to R. And we're asked to show that the angle PQR is 78.5. Be interested to see how you approach this. I would start by working out the journey from P to R and then the lengths of the triangle. So these aren't in relation to the origin. So sorry, James, that first question was question 14 on page 344, although I think it's 343 or 345 in the textbook. And we're now doing question 17 on the same page. Oh, and George as well. I've lost my squirty bottle. Remember, the arrows are important. That's the journey from P to Q, not Q to P. That would be -3, 1, -2. trying to work out P to R. This time, I'm going in the right direction, so it's going to be that plus that. So it's just got to be slightly careful with this. It's a little bit different to the one we've just done. So I always say P to R, how can I get there on roads that I already know? So I've got my third missing vector. Again, just be slightly careful. I suppose I could have done R to P, which would have been the normal minus that and plus that. But because I went that way, it was along that one and along that one. And I've worked out my lengths. We're asked to show that this angle is 78.5. Is anyone going to be brave and tell me which technique we're going to use for this? I'm pleased this question's come up because I said to you, you won't find sine rule and cosine rule on the pre-release information, so we don't need to worry about it. But actually, yeah, we do. This is a cosine rule problem. Remember, the sine rule is about pairs, finding a missing side if you know angles opposite and you've got a pair already. Cosine rule is about corners, and we can use the cosine rule to work out the side opposite if we know an angle and the two other sides. But we can also rearrange it. Here's the cosine rule. It's not on the formula sheet, so it's one we need to remember. I can rearrange that to work out an angle. So if I add 2bc to both, 2bc cos A to both sides, that's one term, so I add it, and take a squared from both sides. I get that, and then cos A is b squared plus c squared minus a squared over 2bc. And do you remember how we label up the triangle? The angle we're trying to find, we call that big A, regardless of what it's called at the moment. And the side opposite we call little a. The two other sides, it doesn't matter which way round we label them, but they need to be labelled B and C. So the cos of A is that squared, which is just 14, plus that squared, which is just 29, take away that squared, which is just 35, divided by 2 times the square root of 14 times the square root of 29, and if you shift cos that, you will get 78.5. So we probably haven't got time to do it now, but why don't you leave a little star and remind yourself to go back and finish that question off. This is an application of the cosine rule, and yeah, we do need to make sure that those things we're ready. It does say in the pre-release information about being prepared for synoptic questions. Those are questions which are not specifically on a particular topic, but which use other skills.
What page are we using?
So it's 343, 344, 342, something like that. Right, so let's look at a couple of other vector problems. If I get my board to work. Oh yes. Right. Working here. We are working here. Excellent, excellent. So here we're told about 4 points. So this is a problem with 4 points. You'll find this question on, well, in the online textbook it's 3, 4, 5, so add one or take away one, I don't know which way around it is. Again, I'm not going to make any attempt whatsoever to work out where PQ and R and S are. However, this question is about a parallelogram. So I'm going to sort of draw 4 points in a roughly parallelogram shape. Doesn't matter if I'm not getting it right. When it talks about a shape PQRS, the points will be in order. So we can either go clockwise or anti-clockwise. So I'm going to go P, Q, R, which must mean that S has to be over here somewhere, but I'm going to leave it just for the moment. And I'm given these as 3D coordinates, so I know how to get to each of those from the origin. Now I had a little bit of a debate with Matt in the other group. He said you don't need vectors for this question, and he's probably right. He's got a bigger brain than me, so I'm going to draw the vectors in. So to get from O to P, it's 4 minus 9 minus 3. And to get from O to Q, that's 7 minus 7 minus 7. And that means I can work out that journey. That's going to be backwards down here and forwards up there, or looking at the jump going from there to there, whichever way works for you. And if this is a parallelogram, then that journey will be the same as the journey from R to this missing point S. And I know how to get to R. So see if you can finish that question off. I'll rub out. I guess I've done this in a silly place. So see if you can work out the journey from Q to P. I'm doing it that way because I'm told it's P, Q, R, S, so S will have to be here if I'm drawing the parallelogram that way. I think in the book they draw it slightly differently, but it's the same approach. So work out that journey, it'll be the same as that journey, and we know how to get to R. it's really easy to get this wrong. So if you're getting it right without fail, brilliant. Ignore this next bit. But let me remind you about the two ways of doing it. To go from here to here, we can either look at the jump from there to there. From 7 to 4 is going down 3. From -7 to -9 is going down 2. From -7 to -3 is going up 4. Or we can say we're going backwards along that road and forwards along that road. So -7 plus 4, 7 minus 9, and 7 minus 3. Really important that you got a way of getting that correct. So if this is a parallelogram, that side will be the same as that side. They'll be parallel and the same length. So that'll be -3, -2, 4. So to get to S, we're asked to find the coordinates of S. I'm doing it as a position vector. All I need to do at the end is twist it. I say, right, it's that plus that. Don't have to write it out, but I just thought I would. I now realise I'm off the video, so sorry. So it's that plus that, which will give me 5 minus 4, 4. So that means the coordinates are 5 minus 4, 4. If you could do it with coordinates without the drawing, you'd be about to ask a question.
Yeah, I got it right, but why can't you have it the other side, if you know what I mean? Like
Yes, you're absolutely right. So if it's described as PQRS, then it's either going to be, well, however the parallelogram looks, and parallelograms come in all shapes and sizes, it's either going to be PQRS in a clockwise direction, PQRS, PQRS, or it'll be PQRS in an anti-clockwise direction, so PQRS like that. So as long as in your initial diagram you get it in that order, you're going to get it right. So where S could go to make a parallelogram with those points, is there somewhere else it could go? Yeah, I think if I put the points like that, it has to be there, doesn't it? Or am I missing something?
I mean, could you go on the other side?
Oh yes, of course it could. Yes, sorry. Yeah, okay. So yes, I see what you mean. Yeah, but then it wouldn't be labelled in that order, would it? It'd be PQSR. So yeah, it's a really good question, and I can remember a student of mine years ago saying, "Oh, you never told us that." You know, if it's described like this, then those points need to be in that order. Yeah, it's a good question. Right, one final example before I shut up. And we're, as I said, we're jumping around a bit. We would normally do a lot more practice. We'll have a little bit of time for some practice at the end. You may remember from GCSE these rather frustrating questions which don't actually have any numbers involved, but which sort of are algebraic, if you like. Here we've got a cube. We wouldn't have had a cube at GCSE because that would have only been in 2 dimensions, but sometimes we had hexagons. So we're given the 3 sides of this cube as journeys, as vectors. So I can say, right, if that's A, because that's a displacement vector, then that'll be A as well, and that'll be A as well, and that'll be A as well. And similarly B and C. I'm not going to label them all up, but any journey in that direction is going to be a B, and any journey of that length is going to be C. Similarly, over here, that would still be a C, even if it isn't part of the cube, still a C. And, crucial to this problem, that's a half of C. That's a half of C. In this question, we're asked to prove that the diagonals, OE, these are 2 internal diagonals, talked about yesterday, back to my sticks, bisect each other. So go on, Millie, what does it mean if 2 things bisect each other? They certainly cross over, but there's an extra bit that we need. Isabel, can we add? They cut each other in half. Yeah, they cut each other in half. So what we've got to show is that the middle of OE, which would be somewhere in the middle here, is the same as the middle of BG. So I'm going to set set some definitions here. I'm going to say let M, let that be the middle of OE, okay? And I need a different letter. Let N be the middle of BG. So I can describe how to get from O to E using A's, little a's, little b's and little c's. And so getting from O to M, which is halfway along that journey, will just be half of that. Similarly, I can write how to get from B to G using little a's, little b's and little c's. Remember, if you go backwards along one of these roads, it's going to be minus that. And so I can therefore half it to get the journey from B to N. There's one final step that we need in order to answer this question. So no numbers now. I think we're always a little bit happier when we have numbers. Just letters. We're getting sort of into vector algebra, if you like. Have a go. See if you can describe those 4 journeys. Remembering that going from there to there, we're just going to half everything. Of course, you can do it by doing B plus A plus C or B plus C plus A. You know, it's the same thing, isn't it? See if you can do the others. And then there's one step missing here in my final answer. There's one step missing. So Pat, have you been able to describe how to get from B to G? So starting from here.
So it would be square root or...
No, I don't want the length. Don't want the length. I just want how I got there. Just like I said, from O to E was A plus B plus C.
So it'd be minus b. It would be the same minus.
It's minus b, but then it's actually
C.
forward along A and forward along C.
Yeah.
So b to n is going to be half of that, which I haven't left myself enough room to write, but that's so I've got the journey from O to N, which isn't a point on the diagram, but it's halfway along O to E. It's in the middle here somewhere. Well, obviously we know it's a cube. We know it's exactly in the middle. And we've got the journey from B to N, halfway along the B to G line. And I want to show that M and N are the same point. That's what I want to show. That would prove that the diagonals bisect each other if they meet at their midpoints.
I might be wrong, but there's no cuboid. Does it make a difference?
Sorry, it is a cuboid. You're absolutely right. Well, it's certainly, it means A, B, and C aren't the same length, are they? But I'm hoping we're still going to be able to prove this. Yes, thank you for pointing that out. So O to M, I know I've got that. That's a half of A plus a half of B plus a half of C. So is anyone able to describe the final step that we need to take? That's it. If I can work out the journey from O to N and work out that it's the same as this, then I've worked out that M and N are the same points. Now I've got B to N already. So all I need to do to turn it into O to N is just to add a B onto it. So if I take that answer there, that's how I get from half of B. If I add a B onto that, which is just the starting bit, that bit, I could have written it as B at the beginning, which is, do you see what happens? We get minus a half B plus a whole B is a half of B, so we end up with the same thing. These two are the same, so we can say M and N are the same point, which means the diagonals bisect each other. And they are frustrating questions, I know. If you feel frustrated by them, then I share your frustration. And there's one other sort of question that doesn't involve numbers. Well, it does involve numbers, but it doesn't involve vectors in either column or unit vector form. It involves it in this sort of algebraic way. And that's this sort of question. Sorry. So this is real sort of algebra stuff. We're told about two vectors. One on the left of the equal sign, one on the right of the equal sign. And the equal sign means they're the same vector. And what that means is that they must have the same I component. They must be going the same direction, same distance in the x direction. They must have the same j component, and they must have the same k component. So I can do what we do sometimes with algebra. I can compare, normally we compare the x cubes or the x squareds or the x's. I can compare the i's. We call this equating. So on the left-hand side, I've got 3 i's. On the right-hand side, I've got p i's. So p must be 3. Go on, equate the j's and the k's for me. See if you can work out the values of q and r. We now know p is 3. This is equating. So if I look at the j's, I get p plus 2 on one side, which I now know is 5, and minus q on the other side. So q must be minus 5. And then looking at the k's, you get 120 is 4pqr, but I now know that p is 3 and q is minus 5, so q times r is minus 15, so we end up with r being minus 2. So, obviously we've got just under 10 minutes left now, just over 10 minutes left now. These are 4 questions which are really worth doing. So I would encourage you to make a start on them now. Now it's page 346 in the online version. I don't know why we said, I think it's, oh no it's not, sorry. It's 347 in the online version. Must be 346 in your version. But these sort of test what we've just been doing. And when you get to number 7, you learn a new name. I've never heard of it before. A parallelepiped, or piped, which is a 3-dimensional figure. It's a 3D parallelogram. But, yeah, I'm hoping that you're equipped now to answer all of those questions. There's one more skill that we need to just finish off. It's just a 10-minute, 15-minute thing we'll do at the beginning of Tuesday's lesson. But if you could have done those questions by Tuesday, that's brilliant. Hopefully we'll get through this first one in the time we have left. I'm going to pause the video at this point. We'll stop the video at this point. So, yeah, online version, have a go at those. In this question 2, it's an isosceles triangle. So when you come to find the area, you don't need to use sine rule and cosine rule. You can use a little bit of good old-fashioned GCSE stuff.